All right, so when it comes to factoring, we've now spent a lot of time factoring our regular cases where you factor when a is equal to 1. Those were the easy ones where you just have to do the x method. And then recently we've been doing factoring where a is greater than 1. So when the front number is bigger than 1, you have to do the x method and then do the grouping method. But now we're going to talk about a couple special cases where when you have these, you can kind of skip all that and go straight to the answer. So we have two types of special cases. First one's called factoring the difference of squares, and then the second one is factoring perfect square trinomials. So we'll go over the first one, factoring difference of squares and what that looks like. So these are binomials. Both terms are perfect squares. So the front term is a perfect square and the back term. So that would look something like, if remember, perfect squares are anything where you take the square root, it equals a whole number. So that would be like if we have a binomial and the front number was 9x squared, because 9 is a perfect square, square root of 9 is 3. X squared is a perfect square because the square root of x squared is x. And then minus, and then the back number has to be a perfect square. So like 4 is a perfect square because the square root of 4 equals 2. So that's what these looks like. So anytime you notice, wait a minute, it tells me the factor and I only have two terms, then that means I need to check and see, okay, are they perfect squares? Because then I can use the factoring difference of squares. So here's an example. We have y squared minus 16. So y squared is a perfect square, 16 is a perfect square. So to solve it, you're just going to take the square root of both terms. So square root of y squared is y. Square root of 16 is a positive or a negative 4, because 4 times 4 is 16, but negative 4 times negative 4 is also 16. So all you do is write it as two binomials, and you write it to where you put whatever you get for the first one in the front of each one. So y in the front, and then you always put plus or minus. So plus in the front, minus, and then the square root of that number in the back. And then you're done. So it's a shortcut to help you go through those problems pretty quickly. So if we go back to the problem I wrote up here, we had 9x squared minus 4. You would just do your binomials, and you would go, okay, what's the square root of 9? 3. So 3 times 3 is 9. What's the square root of x squared? X, because x times x is x squared. Then you put your plus, put your minus, and then what's the square root of 4? 2, because 2 times 2 is 4. And that's it. So you're going to notice everything is going to be exactly the same in your two parentheses, except one will have a plus, one will have a minus. And then the thing I showed and then covered up, this only works if the sign in the middle is a minus. It has to be a subtraction. If you have this same exact problem, but this is a plus sign in the middle, then it won't work. You can't use this method. So let's look at another one. X squared minus 9. So you would just look at it and say, what's the square root of x squared? X. Use your plus and minus inside your parentheses. What's the square root of 9? 3. So x plus 3, x minus 3. All right, so this one's pretty simple. It's all you got to do. Remember, this is called the factoring the difference of squares, and it's called that because you're finding the difference, because it's a subtraction problem, of squares of the square root of each of those. All right, so what would we get for that one? Go ahead and you pause the video and you look at that one, write it down, solve it, see what you would get for that one. So if you did that, paused the video and did that, and you solved it, you would look at it and say square root of 9 is 3, so 3 and 3. Square root of a squared is a, so a and a. Check to make sure it's a subtraction problem. Plus, minus, and then what's the square root of 49? 7 times 7. So that is it for that topic. That's all you got to do. All right, so that one's pretty simple. You notice it when you see you have a binomial, so there's only two terms, and you notice they're both perfect squares. So our next one, perfect square trinomials. Perfect square trinomials. So that's when we look and see how to recognize that they're perfect square trinomials. First off, they're trinomials. And then you'll notice that A and C are perfect squares. So the number in the front and the back are perfect squares. And this looks complicated, but it's not. And if you take the square root of A and the square root of C, if you multiply them together and then multiply it by 2, that should equal your B. All right, so that's how you check to see if it works. So let's check that on this one. So if we look at this term, we know A is 1, B is 10, C is 25. So let's check. A and C are perfect squares. So square root of 1 is 1, so that's a perfect square. Square root of 25 is 5, so that's a perfect square. So that's true. And then now let's see. It says if you do this and it equals B, then you're good. So let's see. 2 multiplied by, what's the square root of A? So square root of 1 is 1, multiplied the square root of C. The square root of C, square root of 25 is 5. So 2 times 1 is 2. 2 times 5 is 10. So if this is our middle number, our B, then this will work. So is 10 our middle number? 10 is our middle number. So true. So if those two things are true, then we can use this method. If it's not true, then we've got to do the longer method, which for this one would just be the X method, but we'll have some later that would have numbers bigger than 1, so you'd have to do the long drawn out method. So let's take a look. All you do for perfect square trinomials is write it as the square root of A. So you take whatever the square root of A is, and then write X, and then you're either going to add or you're going to subtract the square root of C, and then you take it to the second power. So this looks complicated, but let's actually look at the example. So now, next thing, how do you know whether you put adding or subtracting in the middle? If B is a positive number, so if this is a positive, you put a plus in the middle. If B is a negative, so if this is a negative, you put a subtraction in the middle. So that's all you got to do to remember that. So if we look at this problem, x squared plus 10x plus 25. So A is 1, B is 10, C is 25. So all you did, now instead of doing that, we'll just write it out. So I'll tell you how to do it slower. So we look, okay, square root of A. What's the square root of A? What's the square root of 1? 1. So we just have 1x. So we just have x. And then what's this symbol? It's a plus. So plus square root of C. Square root of 25 is 5 to the second power. That's it. Then we're done. So that's a lot faster than doing the X method and the grouping method and all that. All you do is look at it and say, all right, so for example, let's change it up and say, what if there was a 4 out here in the front? So then you do, okay, what's the square root of 4? 2, and then x, always put an x there, and then it's a plus, so plus, square root of 25 is 5, and then to the second power. So let's do another one. All right, so first we got to check, make sure that can we use our method on this. So the first thing we check, is this a perfect square? Square root of 4 is 2. Yep, so square root of 4 equals 2. What's the square root of 25? 5. So are they both perfect squares? Yep. And then if I do 2 times 2 times 5, does it equal 20? 2 times 2 is 4, times 5 is 20. So yep, that worked. So we know that we can use, oh my gosh, having issues. All right, so we know we can use this method. So how do we solve it? We say, okay, What's the square root of 4? It's 2. We have an x, so x. This is a subtraction symbol, so subtraction symbol. Square root of 25 is 5. And then we put it to the second power. And that's it. That's all you do. Square root of the front number goes in the front. Square root of the back number goes in the back. This sign goes right there. So you're basically just doing the square root of this, putting that there. This symbol, whatever it is, goes in the middle. And then the square root of this goes in the back. So if you need to pause the video, write this down, make sure you've got it. You can do that. These are the only two special cases we have. So like it said, square root of a goes in the front, x comes down, it's negative, so minus in the middle. Square root of 25 is 5, and then you always raise it to the second power. That will always be a 2. All right, let's do that one. So check it. Square root of 9 is 3. Square root of 16 is 4. So 3 times 4 is 12, and 12 times 2 is 24. So it works. So now we look at it and we go, okay, what's the square root of 9x squared? 3x. It's a plus, so we put a plus. Square root of 16 is 4. And we're done. That's it. So see, this would have been a problem. You would have had to do the x method. It would have been having to do grouping, and you could still do that. You would have ended up with 3x plus 4 times 3x plus 4. So if you forget, let's say for some reason you're doing your work and you forget to check and see if you can use this shortcut, and you don't do it, and you do the x method and you do the grouping method, you will still end up with the correct answer. You will end up with 3x plus 4 times 3x plus 4, but that is the same thing as this, because it's just saying you have this times itself, which is the same thing as saying that to the second power. So it's a shortcut if you remember to use it, but you won't miss the problem if you forget to use it. So 3x plus 4. All right. Let's take a look at that one. All right, I think we only have 1, maybe 2 left. So pause the video, you do this one, and see what you come up with. So hopefully you pause the video. Hopefully you're trying to do it on your own, so you won't have any questions when you get to your assignments. We're almost to the end of the year, so we only have these notes, and then you're going to have an assignment or 2 with this, and then 1 other note video, and then that's it. We'll be done for the year. So look at this. You should have done, okay, square root of the front. It's a subtraction problem. Square root of the back. So square root of the front, there's no number there, so we just put our m. It's a minus, so minus. Square root of 4 is 2 to the second power. And that's all you put for that one. All right, let's see, do we have another? Yep, we have 1 more. Is that it? Yep, that's it. So last one. Pause the video, see what you got for that one. So let's take a look. You would have square root the front. It's a positive. Square root the back. So we look at this and we go, okay, square root of 4 is, wow. Yeah, just realized I told you to do the problem and I had the answer showing the whole time. So, all right, anyway, make sure that's what you would have got. So the square root of 4x squared, square root of 4 is 2. Square root of x squared is x. It's a plus sign, so you put a plus sign. Square root of 49 is 7, and then you raise it all to the second power. All right, so if you have any questions, come to the Google Meets, email me, let me know. I think you all do pretty good with these two, but these are the 2 special cases you will get. So these are something you always should check for when you're doing these problems. Difference of squares, Do you have a binomial where the front and back are both square roots and there's a minus in the middle? Or factoring perfect square trinomials where the front and back numbers are perfect squares, and if you take the square root of them and times it by 2, you get the middle number. That's how you check those. So good luck, and let me know if you need anything.